Hey everybody, welcome to Homework 10 Part 2. So for this question, we're going to be ranking the following compounds in order of lowest to highest boiling point. So we've got some diatomic gases down here. We've got chlorine, iodine, fluorine, and bromine. And our game plan for this is going to be that we want to rank our compounds from weakest to strongest intermolecular forces. The strongest intermolecular forces mean that those compounds are going to be attracted to each other the most, or they're going to have the strongest attractions between particles. If we want to cause something to boil, that means that we need to cause those particles to separate from one another. So we need to get them to spread out. If we want to get particles to spread out, we need to overcome their intermolecular forces. So the stronger the IMFs, the more energy it's going to take, and thus the higher boiling point. So that's why we want to rank from weakest to strongest intermolecular forces. Fortunately, all of these compounds only display London dispersion force. These are all nonpolar gas molecules. So what we can do, instead of difficultly studying all of them, we can just look at their molar masses. If we look at the molar mass for compounds that all display London dispersion force, whichever compound has the greatest molar mass is going to have the strongest London dispersion forces. So we have everything ranked out by molar mass. We see that the molar mass of fluorine is 38 grams per mole, chlorine is 70 grams per mole, bromine is 169 grams per mole, and iodine is 254 grams per mole. That means that my ranking of London dispersion force, say that fluorine has the weakest London dispersion, chlorine has the second weakest, bromine has the third weakest, and iodine has the strongest. We then just line that up in terms of our boiling point as well. So because we have the weakest IMFs here, we have the lowest boiling point. We have the strongest IMFs over here. We have the highest boiling point. It's going to take the most energy to separate these iodine particles. And it's going to take the least energy to separate these fluorine particles because the fluorine particles have very low intermolecular force. So we don't need a lot of energy in order to overcome that and make those particles separate.